Hi everyone, this is your practice problems video on geometric proofs. So there are 6 proofs, I believe, on here. Yep, 1, 2, 3, 4, 5, 6 proofs that we're going to look at. So the way this is going to work is I am going to show you how to do 1 or 2 of them that are similar, and then I'll give you a chance to try one on your own and then come back to the video and check your answers against mine and see how you did. All right. So here, let's take a look at this first one. So we're given this lovely diagram. So a good idea whenever you're doing a proof problem is to mark anything that you know is congruent or equal to each other, depending on what's given to you in the problem. So let's go ahead and just start there. This one will be a little easier for us to do because we have the statements written out for us already, and we just have to fill the reasons in. So we were told that PM is congruent to MS. So I'm going to mark that with a little dash. That dash means congruent. Okay, and then it says RS bisects PQ. Okay, so what that means is that PM and MQ have to be congruent. So the congruence mark that I have on PM is one little congruence mark, which means I can put the same congruence mark on MQ. Okay, so that's essentially all we need, because if you look at the statement, we are just trying to prove that MS is congruent to MQ, which we've already shown just in the picture. So let's go ahead and write that out and write out what all of our reasons would be and things like that. Okay, so I think my text might be a little bit too big here. So let me see if I can change that, make that a little bit smaller. Okay, so here, our very first reason is PM is congruent to MS, so that was given to us. Remember, you always want to start with exactly what is given. And then RS bisects PQ is also given. Okay, so the first two are pretty easy, those reasons. Okay, then reason 3 says PM is equal to MS. Okay, so remember, whenever you are going from equal to congruent or back the other way, that is the definition of congruence. Okay, so essentially what we did here is we took this step 1, right, and converted it to equals. We did congruent to equal. Okay, all right, then so that gave us our step 3 there. Okay, so how we were able to arrive at step 3 was through this definition of congruence. Okay, so then step 4 says PM is equal to MQ, and we got that from the bisector rule. Okay, so this, we would do this as the definition, that's not how you spell definition, of a bisector. Okay, so what we did here is we took step 2 and said, okay, if RS bisects, then that means that the parts have to be equal, right? Right, so bisect means equal parts. Okay, and I'm mostly writing this stuff out on the left side for you all so that you can kind of see the thought process and how the steps above connect to the steps below. You do not have to write this out when you're doing a full proof on your own. Okay, so step 5 says MS is equal to MQ. So if you look at steps 3 and 4, you see that MS and MQ are both equal to PM. So if you remember, we can write this in a chain. MS equals PM, which equals MQ, right? And then remember the rule here, we remember the transitive property is you can cut out the middleman and then you're just left with the tails on the end. So my reason here for step 5 is I use the transitive property. Okay, that's the transitive property, right? We combined steps 3 and 4 into step 5 here. Okay, and then the very last one, we went from equal to congruent, so that is also definition of congruence. Okay, so just to reiterate, right, we took steps 3 and 4 and combined them using the transitive property to get to step 5. And then for step 5, to get from step 5 to step 6, we went from equal to congruent, okay? And that is the definition of congruence. That's how we arrived at step 6. All right, so that's the first one. A pretty simple proof, but I'm hoping you can kind of see how everything connects, right? And how the reasons connect to the statements. All right, so let's look at one more where we have the reasons filled in and they want the statements. So let's give this a try. All right, so for step 2, or for problem number 2, they said MB is equal to MQ. Okay, so I'm going to mark those with a little congruence sign. And we want to prove that AB, which is this whole thing, is AM plus MQ, right? Well, we already know that AM plus MB has to equal AB because that's the segment addition postulate. That's the part plus part equals whole thing. And then we're going to do a little bit of substitution here, okay? So remember that whenever you're doing a proof, that you always want to start with exactly what is given to you. Copy it exactly as it's given to you. So that was MB equals MQ. That was given to us, okay? Then the second statement here has to have something to do with the segment addition postulate, right? So there's 2 segments on there that you could add up, right? You could do PM and MQ to make PQ, or you could do AM and MB together to make AB. And if you look at your proof statement, what I actually care about and what I want to end up with is AB equals something. So I have to get that equation, I have to get AB onto my list, onto my proof somewhere. So I'm going to write an equation for the segment addition postulate, which is AM plus MB, so that's part plus part, has to equal AB, right? And so my very last step here, we're using the substitution property, but essentially what we're doing here is we're saying, well, I want, instead of MB right here, I want it to be MQ instead. So what I'm going to do is I'm going to say, well, MB and MQ are equal, so I'm going to put MQ right where MB used to be, right? So I'm going to take at step 2, in order to get from step 2 to step 3, I have to plug in MB. Or sorry, I have to plug in MQ, apologies. I have to plug in MQ for MB. And remember, whenever you plug something in, that's the substitution property. Remember, I call it the plug-in property. Right? So now what's great about this is I can just write my proof statement exactly as it's written. AB equals AM plus MQ. Right? I took MQ and plugged it in where MB used to be in order to get my proof statement, right? So one of the things that's kind of nice about proofs is that you have, like I said, you have your starting point and your ending point given to you at the start. So if you have a short proof like this, you don't have too much to fill in the middle, which is kind of nice. All right, you guys. So we've got one more here. So I want you to give this one a try on your own and see how you do with it. Okay, there's a lot of stuff that's given to you. So a lot of your reasons at the start are going to be given. And then I would mark some things as congruent that you know based on these midpoints that you see up here. All right, so give it a try and then check back in a second and see what your answers look like. Compare your answers to mine. So I'll see you in just a second. All right, folks, so here is your completed proof. Now, I'm going to preface this by saying you may have done this in a slightly different order than I did, which is okay. With this one and with a lot of proofs, as long as your reasoning is valid and your steps are logical, then you can do things in a slightly different order, and it's okay as long as you end up at the same point, okay? So what we have here is we have these 2 segments yes, BOY. And we're trying to show at the end that ES is congruent to OY, right? And we have a little bit of information. We know that YE, right here, oops, let me switch the color on that one so it's a little easier to see. Okay, so we know that YE is equal to BO. So I'm going to go ahead and mark that with a little congruence symbol. They also said E is the midpoint of YS. So what that means is this part and this part right here are equal, or you can think of it as congruent. Okay, so if this has the little 1 congruence mark, that one also has the 1 congruence mark. Okay, and then we have another similar statement that says O is the midpoint of BY, which means that this part and this part have to be equal. So if this one's already marked with a little 1 congruence mark, then this one also can be marked with a little 1 congruence mark. And if you just look at the picture, we've shown that ES is equal to OY, because see how they both have the same congruence mark on there? Okay, so we just have to take that and turn it into a 2-column proof. Okay, so we started with our 3 given statements. All 3 of these are given. Midpoint, midpoint, and then YE equals BO. Okay, so then what we want to do is take the information that we have, that we know for sure, and say, what other statements can I write from that? And I had that the reason for step 4 was definition of midpoint. So I just said, okay, if E is the midpoint of YS, then that means the parts are equal. Okay, so I used information from step 1 in order to arrive at step 4. And the reason I used is definition of midpoint. Okay, so then what I did next is I said, well, that means BO has to equal ES. Okay, so what I did is I took these 2 steps, 3 and 4, and I combined them with the transitive property, right? Because see that they have something in common. They have a link, a middleman here. So I did this, BO equals YE, which equals ES, right? I cut out the middleman and I'm just left with BO equals ES, right? So I took these 2 and I combined them to make step 5 using the transitive property. Okay, right? Then I did a very similar thing for my other midpoint, right? So here's another thing that I want to make sure that you know about proofs is that all of the information that they give you for a reason, right? They give it to you because they want you to use it. So I haven't used this reason yet, right? That O is the midpoint of BY. So I'm going to use that to write step 6. And sorry, my arrows are getting a little bit mixed up here and put together. But if O is the midpoint of BY, then that means the parts are equal, which is exactly why I'm able to write this equation right here. BO is equal to OY, right? And then I'm going to do the same thing that I did for steps 3 and 4, combine steps 5 and 6 using the transitive property to make or get to statement 7. Okay, so that is my whole proof there. All right. Okay, so these proofs that we've looked at so far have all been segment proofs. There's one more segment proof at the end, but I want to do one example for you here that is an angle proof. Okay, so this one is a little bit different, a little bit. It's just a little bit different, but not too bad, I promise. Okay, so this one does use a rule that you may not have heard of yet, but that's all right. It's something that you may know about just in general. But so let's talk about this one a little bit. So all we're given is that AB is perpendicular to BC. Okay, so I have this right angle right here, right? That's all the information that I'm given. Okay, and one other thing that I know about triangles is that all triangles add, or the angles the angles in triangles add to 180 degrees. Okay, which again is not something that you all will know yet, but that's something called the Triangle Sum Theorem. Or rather, you might know it, but it's not something I've explicitly told you. Okay, so that's kind of what we're going to use to figure out and complete this proof here. Okay, so as always, for our first statement, we're going to start with whatever was given to us. Oh dear. Sorry, everybody, it's indenting in. Okay, so what was given to us is that AB, I'm going to leave myself a space because I'm going to have to draw it. AB is perpendicular to BC. Right? So I'm going to draw my little perpendicular thing here and put my lines over. Okay, and then my reason for that is given. Right? All you have to write is given. Let's see if it'll allow me to. Yes, it will. Okay, so what I have to do is think, okay, if AB is perpendicular to BC, what does that mean? Right? What's something else that I know if I know that those lines are perpendicular? And what I know from the definition of perpendicular is that that means that angle B is or equals 90 degrees. Okay, and the reason I know that is because that is the definition of perpendicular. Okay. All right, so now we're kind of at a loss because we can't really, we've already used our step one, and we've used it to come up with another statement. So we don't really have any other given information that's going to help us, but we do have this triangle. So this is where our triangle sum theorem is going to come in. So I know that angle A plus angle B plus angle C has to equal 180 degrees. And again, the reason for that is because all triangles, whenever you add their angles up, it always equals 180 degrees, no matter what the shape is. It does not matter, no matter what type of triangle. The sum of the three angles in a triangle is always 180 degrees. And the reason for that, the theorem that we use for that is called the Triangle Sum Theorem. You're literally adding angles in a triangle, okay? Well, now we have two steps that we can kind of combine, right? I have B equals 90, and I have an angle B in this equation right here. So let's go ahead and plug that in, right? So I have angle A plus 90, right? Instead of angle B, I'm going to put 90, plus angle C has to equal 180, right? So remember, whenever we plug something in, right, for something else in an equation, that's the plug-in property. That's the substitution property. Okay. So that is the substitution property, right? And now I have an equation that I can do some solving with. So really what I need to do is move this 90 over to the other side and get rid of it. So I'm going to subtract it, right? And when I subtract it, I get angle A plus angle C equals 90, right? Remember, the key thing with proofs is you don't have to show the work, right? You don't have to show the actual subtraction because you're saying that the reason is the subtraction property. Okay, remember, it's the subtraction property because we are subtracting the same number from both sides of the equation. All right, so now I have this equation, angle A plus angle C equals 90. And my end goal is to show that A and C are complementary. Well, I know that complementary angles add up to 90. So I have two angles there that add up to 90. So I'm at the end of my proof. I can say angle A and angle C are complementary. Okay, and the reason that I can say that is because I'm taking the equation for complementary and converting it to the definition, right? So I'm using the definition of complementary. All right. All right, so I'm going to scroll down just a little bit. That is our completed proof there. Okay, and then I would love for you to try 5 and 6 on your own. If you want to start with a slightly easier one, 6 is easier of the two that are here. So try these, see how you do with those, and then come back in just a second to check your answers against mine. All right, folks, so let's take a look at number 5. Okay, so this one was a slightly longer proof, and you needed to use your knowledge about supplementary angles here, or angles, remember, that come together and add up to 180 degrees, or angles that make a straight line. Okay, so here, we started obviously with what was given, and I just realized when I'm looking at this now that I forgot to make all of these congruent symbols. Apologies. Let me just add that in really quick. I don't have the ability to type congruent symbols with what I'm doing here. So I'm starting with what was given to me, which is that these two angles right here, ABD and BDE, are congruent. They're marked with their congruent symbols, right, using the little arches. And what we're trying to show is that these two angles right here, this angle and this angle, are congruent. And just looking at the picture, it kind of makes sense that they would be congruent. Because the angles that they're directly attached to, which both make straight lines, are congruent, right? So if you take away those two green angles that are both the same, you should be left with two other angles that are also the same. So that's essentially what this proof is doing, okay? So we started with what was given, okay, and really that doesn't give us a whole lot of information, not yet. We don't have something directly from that statement that we can go, okay, and what else do I know based on that? I don't really know anything else based only on that first statement, but I do know some things based on the picture. So that's where steps 2 and 3 came in, that I said angle ABD, which is this one, plus CBD, which is this one, that these two together have to equal 180 because they make this straight line, okay? So the reason for that is that's the definition of supplementary angles, or sometimes they're called a linear pair, right? Because it's two angles that come together and make a so pair that come together and make a line, linear, okay? And I can do the exact same thing on the other side. I can say angle BDE, which is this one, plus this angle CDB has to add up to 180, right? Because they come together and they make this straight line, right? So those have to be 180, right? So I've used the same reason for both of those. Now that I have these two equations, okay, I can say, okay, well, what else do I know based on these two equations? And remember, if you look at them, they have something in common. They're both equal to 180 right here. So I can use the transitive property. This is my middleman. That I'm going to eliminate, okay, by combining the two more complicated parts, the angles that are being added together. Okay, so I have ABD plus CBD, right, is congruent to BDE plus CDB. Okay, so what we did is we combined these two equations and we said we can combine those and write a new equation with the transitive property. So I arrived at step 4. The way I got to step 4 was using the transitive property. So that's why the reason at step 4 is the transitive property. Okay, and now I'm going, well, okay, what reasons have I not used yet, right? What statements have I not used yet? And I haven't used this one, right? Remember that in proofs, they're never going to give you something that you don't need. So they told us this because we will need it in order to complete our proof. So I have in this equation, you can kind of see it on the side that you have the makings of the end statement for this proof, right? If you look at statement 4, you have CDB on the left side and CDB right? These two angles like have too many similar letters that it's hard to keep track of them. But you have CBD on the left side, which is what you're supposed to have in the proof statement, and you have CDB on the right, which is what you're supposed to have in the proof statement. But then we have these other two things in the way, ABD and BDE. What would be great is if we could subtract those and get rid of them, right? Well, I know that those two are congruent. So what I'm going to do is I'm going to say, I'm going to plug one of those in for the other, right? So I need to plug in so that way I have something that's the same on both sides so that I can subtract that extra angle away, which is exactly what I did, right? Angle 1 up, or not angle 1, oh my goodness, statement 1 says ABD and BDE are congruent. So instead of writing ABD right here in step 4, I replaced it with BDE in step 5, right? We did a plug-in. Remember, plug-in is always the substitution property, right? And now I can get rid of BDE on both sides because I can subtract it out. Okay, so when I subtract it out, these are eliminated, so all you're left with is your end goal. CBD is congruent to CDB, right? And remember, I got from here to here by subtracting angle BDE. So because I got there using the subtraction property, that's how I arrived at statement 6. So my reason is the subtraction property, right? It's a little tricky. This one definitely was a little bit longer and a little bit trickier, right? So a good rule of thumb is if you see things that you can add, right, using the segment addition postulate or definition of complementary or supplementary, or your angle addition postulates, there's anything that you can add, any equations you can write based on the picture, that's usually a good idea. If there's anything that you can mark as congruent based on the picture and based on the information, that's usually very helpful because it allows us to use the transitive and the substitution properties, or maybe even the subtraction properties. All right, so let's take a look at this very last one. This one was pretty short. We were told that xy is equal to 6 and xz is equal to 14. So they want us to prove that yz equals 8, right? And we kind of know that already because we know how to use the segment addition postulate, right? We know that we have 6 plus x has to equal 14, and then do some subtraction in order to figure out what x is. Okay, so we're basically going to do that in the proof here without writing out all the math steps. Like I don't have to write -6 and -6 when I do it in a proof, right? I don't have to do that because my reason is the work that I'm showing. Okay, so statement 1 is just what's given to us. Then they said xy plus yz equals xz. So that's the segment addition postulate. That's your part plus part equals whole. Okay, and then they said, well, I know that xy equals 6 and xz equals 14, so I'm going to plug the numbers in, right? So going from here to here, I did a plug-in, okay? And plugging in is always the substitution property, right? And now my very last step here is I did -6 on both sides, right? So I took this step, step 3, in order to get to step 4, I did -6 on both sides. So since I did -6 on both sides, and I subtracted the same number from both sides, I get this, that is the subtraction property. And now I am all done, because if I go back up to my proof statement, my last statement in the proof and the proof statement match exactly, which is what I want. All right, folks. I know that geometric proofs can be a little bit tricky when you're first learning them. So if after watching this video you still have questions and you're going, I still don't quite understand how to do this, please come and see me during my office hours so that I can help you grasp these concepts a little better. All right, I will see you all in the next video. Bye, everyone.